So welcome back. So till now we have seen two pointers moving in the same directions. Both the two problems that we have solved, in both case pointers are moving in the same direction. Okay. Now we are going to see or going to explore a new dimension. So two pointers moving in the opposite direction. Okay. So this pattern is extremely important for the interview purpose, and this particular problem is a very classic problem. It tests whether you can think optimally or just code. Okay, so let me iterate the problem again. So what is the problem statement here? It says you are having a array of heights. Okay, we are having the array of heights. Like example, you can take like any random heights, something like that. We have to find two lines in such a way that they form a container and store the maximum water in this. Okay, so to store a water you need two lines, right? And the water is nothing but it's the area of a smaller line multiplied by the distance between these two lines, right? So it's nothing but a smaller height multiplied by the distance between the two lines. Right, this line. If h, this is d, then h into d. Correct? So here each value represent a height, and you can pick any two indices and then they form a container, right? So let me take some example. Suppose you are having one line, and this is called width, and let me have your multiple heights. This is one height. Okay, you are having this one heights. Okay, you are having this one heights. Okay, something here also. Okay, so you are having some heights like that. Correct? So suppose if this height is measured by here, it's a 2 height. Let me write 0, 1, 2, 3, 4, something 5, and both are the same height. Okay, remember this. Alright, so this is a 3. So it says how much water you can contain. So see here, water can be stored between two heights. Let me take this example first. Suppose these are two bars I am taking, 1 and 2. In between these two bars, water can be stored here only, right? Water can be stored here only. Between these two bars, water can be stored here only. Alright? Or between these two bars, water can be stored here only. All this, right? So if you observe here, water that can be stored depends on two things. What is the first thing? Width between the lines. Right? And second point, minimum height of the two lines, because the area is limited by the minimum heights, not by this. Here we can't store water, the little fall, right? So our area is going to be limited by this particular height. I mean minimum between the two lines. So minimum height between two lines. Correct? So if I draw a formula, so what will the formula now? Area equal to minimum of height of left line, comma height of right line, right? And whatever it is coming is going to be multiplied by right minus left. I mean, this is the width, right? Is correct? I hope everyone, we are on the same page, right, for this formula. Okay, now let's start with a very simple approach. So what is the simple approach? I can check for every pair, okay, and calculate the area and take the maximum. Means I will check every pair. Like, let me take one more example here. Suppose this is the height, 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 and this is the height, right? Multiple. So 0, 1, 2, 3, 4, 5, 6, something like that is index. So every pair I am going to take and I calculate the area, and I have to take the maximum area for the maximum order. Then I will take this pair, some area, whoever some maximum I am going to store in a max variable. Okay, till this point this is the maximum order. Then I'm going to get this line. So for this pair 1 and 3, water can be stored in this much. So now max will be this one, right? Then again this element, so this can be this much for this line, right? And for this I can't take this because limited by the minimum heights, because after this I cannot store water, it will fall. It cannot stop, right? So this much water I can store here. So this is the max. Then in max variable we'll have this height now, this area now. So the approach is that try all pairs, right, I comma j, and calculate the area, correct, and then take the maximum of this. Right? It's going to work, right? Now what is the complexity of this? It's going to be to find out all the pairs of any array, you require 2 loops, and 2 loops means nothing but order of n square. So, and this is not acceptable in interview, because for the larger set this is going to be take too much time. Okay, so the question is now, can we do better? Is there any way that you can reduce this complexity to some linear approach, linear one? So let's observe something here, very important. Okay, let's take our example again. That was 1, 8, 6, 2, sorry. Okay. All right. This is the 0 index. So what I'm going to do now? I'm going to take one left pointer here. So left is, what is the left line? Is 0. 0, what is the height of this? Height equal to 1, right? For the right one, this is left one. For the right one, this is 8 here, right? 8, and okay, so we are going to take the approach of, because in this approach, even though I'm taking the left or right here, I cannot do, again I'm going to do the pairing. So this approach is not going to work. So what I'm going to do now, I'll change bit, and I'm going to remove this pointer, and I'm going to apply this here. So now 2 pointers on the opposite side, and they are coming now towards each other. Okay, it will move this side, this will move this side. Correct. So height equal to, let me remove this now, the height equal to now 7. Correct. On the right side, height equal to 7 and writes at the 8 index. Right. Let me write it again, it's a little bit left 0, height equal to 1, right at 8, I mean 8th index, and height equal to 7. Correct. So we know that area is limited by the smaller heights. Okay, so which one height is small? So a smaller height is 1 between these two. So even if you move the taller line, it's not going to help, because on the line, if this is the height, this is the left, this is the right, even you are moving the taller, this area is not going to be impacted, because the area is controlled by this one, the minimum between these two lines. Correct. So any line which is greater than this on the right hand side is not going to help. Okay, so if we want to increase the area, we must move the pointer pointing to the smaller height. Okay, suppose one smaller line is here, so area is what? Area is this one, right? So I want to increase this area, then I have to move the pointer pointing to the smaller height. The smaller height is not here, so we have to move our pointer towards this. So always move the smaller heights pointer. So this pointer left will move here now. So area will be increased. Then you have to take the maximum of that, right? So let's do, I think when you do the, on a step-by-step process, so it might be clear. Okay. So let's do the setup now. What I was saying, I am having some element. This is my left pointer, this is my right pointer. Correct. Let's start at beginning and right is start at end. Fine. So what is step 1 now? Left is at 0, height equal to 1. Right is at 7, sorry 8, this is the index, right? Right is the 8 and height is 7. So total width, how much we are getting? Tell me. It's 8, right? Difference between left right minus L. So 8 minus 0, that is nothing but 8. Correct? And mean height is nothing but minimum between left and right. So that is coming now 1. So you can write it like mean of 1,7, that is nothing but 1. So area will become now 1 multiplied by 8, that is 8, and max. So for till now this point, the max area, the max water that I can store, that is 8 unit, right? So smaller height is left, so move left. Okay, now coming to step 2. So in step 2, what is happening? Let me copy this data. So let's copy this now, the data is required, and I'm going to paste here. Okay. Okay. So in step 2, what I'm going to do, I am going to move my left pointer because left was small, right? So I'm going to put my left now here. Now left is here, so left at 1 and height is 8 now. Right is at same place, nothing changed. Height equal to 7. Now width equal to, we have to do how to calculate the width, the position between these two, the 8 minus 1, that is 7. Okay, so width is 7. This is the width. And what is the mean height? Mean height is nothing but a minimum of 8 and 7, so mean height is 7. So what the area is coming now? 7 multiplied by 7, that is 49 unit, and max it will be now. Earlier what was in the max? 8. So of course the max will have the max value. So 49 now is with max. Correct? So now a smaller height is on the right hand side. Correct? A smaller is at right hand side. So we are going to move right side now. Okay, so let me again do the copy paste here. Okay, I'll simply come here and we are going to do now step 3. Correct? So I'm going to move my right now. Okay, so L is at 1, there is no change, height equal to 8 as it is. Right is as equal to 7 and height is now changed, height equal to 3. Correct? So again same, width equal to, width is nothing but distance between these two, so that will come now 6. Okay, because you are going to do 7 minus 1. Then what is the minimum height? So minimum height is equal to 3, 8, so that will come now 3. So area 3 multiplied by 6, that is 18. So we are not going to change anything because max we already have. 18 is less, so I am not going to change the max value. Max will keep the same value, that is 49. So now a smaller height is at right hand side still, so I have to move right now. So in the same way I'll do the step 4. So in step 4 I have to move right because right was small, so let me do that now. Right is here now, so again same thing I'm going to do. Left equal to 1, nothing change. Height equal to 8, right equal to 6 index, so 6 is nothing but height at 6 equal to 8, and width equal to 6 minus 1, so it's 5, and minimum height equal to minimum of 8, 8, so it's nothing but it's same 8, right? So area will be now 8 into 5, that is 40. So max is not going to change because still 49 is greater than 40, so max will be 49 in this case also. Again here height is same, height is equal, so we can move anyone. Okay, so let's say I'm going to move right. Okay, in case of equal, remember we can move left also, you can move the right also, so I'm taking the right one. So now coming to step 5, let me do the some copy paste work. Sorry, so let me copy this again. In step 5, what I'm going to do, I'm going to change the pointers again. Correct? So let me erase this now. Now R will be at 5th place. Correct? So L equal to 1, and for L equal to 1, height equal to still 8, right equal to 5, and height is at how much? 4. Correct? So width equal to how much? 4. 5 minus 1 is 4, and minimum height is nothing but 8, 4, so it's going to give you 4. So now area will become 4 into 4, that is 16, and max is not going to be changed, so max will be 49 always. So again, minimum is, height is right, so I'm going to move right again. Okay, so let's move to step 6 now. I'll do some copy paste. So I'm going to move right to the left side, so it will come here. Now right is here. Correct? So what is happening now? Left equal to 1, there is no change in that. Right equal to at 4, 4th place. Correct? So height will become 5. Sorry, I think I just made one mistake. Right is not here. Right will come from 4 to 5 here, right? So it will be here somewhere, here. Correct? Sorry, it's my bad. I just in copy paste I missed one element. I skipped that actually. Okay, coming to the point now. So right is as 4 and height is having 5. So how will be the width area? So width is now 4 minus 1, that is 3, and minimum height is nothing but minimum of 8, 5, that is 5. So now I'm going to calculate the area. So 3 into 5, that is 15. Correct? So max is not going to be changed. Max will continue to have 49 because it's greater than 15, right? So there is no change in that. Now what will happen? Which one is the minimum? Right side, I'm going to move right again. So that will be step 7, right? Step 6 is done, right? Step 7, correct. So in this iteration, I'm going to do again the copy paste. So now right will move towards the left by 1. So I'm going to remove this, and I will put here. The right is now at the 3rd index, I mean 2. So left equal to 1, and height is still 8. R at the 3rd index, and height is 2, right? So width equal to 2, and I'm doing the index minus 3 minus 1, that is 2, and minimum height equal to 2, minimum of 8, 2, right? So area again, it's a smaller one, 2 multiplied by 2, that is 4. So max is not going to change, max will be keep on 49, right? So since right is smaller, again I'm going to move right towards the left. So that will be my step 8. So again I'm going to move this R. Now R will coming here, index number 2, correct? So left pointer at first position, and height is 8, right as second position, and height is 6 now. So width is very less, that is nothing but 2 minus 1, that is 1. And so minimum height, if I calculate, then 8, 6, so 6, and multiply, so area will become now 6 multiplied by 1, that is nothing but 6, correct? And max is continuing to be having 49 because 6 is smaller than 49, so it can't change that, right? Now after that, I'm again, the smaller is the right one, so again right is going to cross this. So now in the step 9, L become R, so we are going to break this loop. Okay, so what is the final answer? Your max area. So max is having 49, so your answer will be 49 unit of water can be, container can save maximum. Okay, so this is the whole process. Now I feel you might have got the idea like how you are moving that. Okay, so let me write the pseudocode for this. So pseudocode will be like that. Okay, so left equal to 0, right at the end, so n minus 1 and the length of the array, and max area we will initialize with 0. Correct? So while left is less than right, means both index are not same, then do something. So area equal to minimum of height left comma height of right, and what are the minimum is coming, I'm going to multiply with the width, that is nothing but difference of right minus left index. Correct? So max area equal to, now whatever we are having this max, so it's nothing but it will be going to be the max of max area comma current area. Correct? And now we're going to check if height of left is less than height of right. So what are we going to do? We have to move the smaller height, you know that, right? So what are we going to do here? So left is small, so I'm going to take left plus plus, right? Otherwise right minus minus. These things I think is correct, and you might be on the same page. Okay, so whatever writing might not be very good, but whatever I'm speaking, just try to sync that part. Okay, and once this loop is over, then whatever you are, return the max value, that return that max area. Correct? Okay, so hope this thing's clear to you. And so this problem teach you a very powerful idea. Not all movements are useful. We move only pointers that can improve the result, right? So let's see the code for this in the Java in the next lecture.